Yo, what up guys, iReapism here, and welcome back to another video. Today we will be talking about some of the things that never made it to my last video. Specifically, we'll be talking about password cracking and unique strings. We will talk about how safe a password is from being cracked, and what else my program does. In order to proceed, I need to establish some information and terminology so we become familiar with what I'm saying. So we need to understand that processor speeds are measured in IPS, or instructions per second. My processor runs about 100,000 MIPS, which is 100,000 millions of instructions per second. And when you evaluate that to regular IPS, that's roughly 100 billion instructions per second. Now that we understand that, we can talk about methods of cracking strings or passwords. There's one method called brute force cracking, which tests every possible password configuration until it succeeds. Brute force cracking is 100% guaranteed to crack a password. It will never fail, ever. The problem with brute force cracking is that it takes a very long time to complete. Every time the length of a string is incremented by 1, it becomes more difficult to crack the string. There's much more permutations of that string, which makes it unfeasible for password cracking in the modern day. There's one scary method that exists that many hackers use to crack strings, and it's called dictionary attack. Dictionary attack essentially uses words to narrow down the possible passwords. Now let's stop here for a moment. All of us use passwords to securely identify that we are the account owner. However, we tend to use recognizable words in our passwords to help us remember them. Although it is unlikely a person can hack your password given a certain amount of time, someone with the intent to hack millions of accounts, for example, the fake posts that you always see on Facebook, the intent to maliciously create fake posts with a non-recognizable link happen all the time. Again, you see it all the time. We use passwords as a way for us to confirm that we are the account owner. We need to be careful because if we use words in our passwords, the dictionary attack becomes increasingly effective and resorts in an extremely viable way to crack passwords. A decent computer can check billions of passwords a second, and when they use dictionary attack, the effect is devastating, leaving so many vulnerable accounts to a basic algorithm for sinister hackers to take advantage and reap our account. A quote from an example of password cracking follows: "Graphics processors can speed up password cracking by a factor of 50 to 100 over general purpose computers. As of 2011, available commercial products claim the ability to test 2.8 billion passwords a second on a standard desktop computer using high-end graphics processor. Such a device can crack a 10-letter single case password in one day." That is an example of brute force cracking, which is not common, by the way. So you're gonna crack a 10-letter single case password in one day using brute force cracking. That's scary. That is so scary. Anyone could crack that password in a day. That's crazy, guys. Now we have to establish that this was talking about graphics processors, and you might be wondering, like, what's the difference? CPU versus GPU? Well, in layman, and the absolute minimum reason for this is that most CPUs run the same instructions on each core, and graphics cards doesn't. That's basically the most minimal way I can explain it to you. Okay, so assuming this password can have capital and lowercase letters and numbers, which is 62 to the 10th power, It is about 839 quadrillion different permutations of that string, which would take 3,469 days to crack, or 9.5 years. Now remember, this is using brute force cracking, which is not common. So people commonly use dictionary attack, which would lower that time considerably, enough to scare you. Also, the true power of increasing the number of permutations comes from the string length and not the character list, which may seem pretty obvious to most of you. So essentially what I'm trying to say is, if you have passwords that use words in your password, dictionary attack becomes very viable, and you're susceptible to password cracking in a much smaller finite time. Now let's talk about strings. So there's an average of 87 words in a sentence, according to this study. Examples of an 88 character sentence would be, "Greetings everyone, this is an actual English sentence that has 88 characters," versus this monster. Now you can notice two main differences in this password. One seems to be in order, and one seems to be randomized, and one actually is readable and the other is not. Those are the two main differences. They both contain 88 characters and can both be represented using a random function and have very low probabilities of occurring. So scientific notation for each of those character sentences of 88 characters long is 57 to the 88th power. The approximate permutations of all of that is 3.2 times 10 to the 154, which is finite, of course, but to crack a string that big would take more time than there is in the universe, basically. Now, why do I bring up strings in this? Is that my program, guys, since you can alter the string length right in front of your face, and it immediately generates a new string in front of you, and it tells you the permutations, and you can see how much it blows up, you can theoretically, given any character length, generate every possible sentence, every possible arrangement of those characters ever. Seriously, if you sat there and pressed generate string on any character length, it is possible, given that you're extremely lucky and that the permutations isn't so high, that you can generate a string that talks about the name of your child's 64 or any number of generations in the future, and what their accomplishments are and what they didn't accomplish. It's a really neat thought experiment, and I like to emphasize that it will generate everything that's not right about them or that's not true. The thing I took away from writing this program was not that I wanted to design it to be the most useful thing in the universe, no, but instead the idea that it's able to do these kinds of things given a certain amount of time. I just find that remarkable. It's just such a amazing thought that you can write programs to do things that is completely not feasible in the natural world. And by natural, I mean without technology. I hope you guys enjoyed watching this video. It took a while to put together and how to illustrate the usefulness of the program, but I took a lot of time to think about it, and there's really good applications for this program that you can find. But anyways, I hope you enjoyed. Thanks so much for watching, and I'll see you in some other video that I'll make. Bye.